All right, in this next video, we're going to talk about ions that go in to make compounds. Ionic compounds are formed when a metal and a non-metal react. So that's very important to be able to look on a periodic table and say, what is a metal and what is a non-metal? We talked about that in our previous talk, so I'm not going to go over that now, but everybody needs to know that. You need to know that fast and quick. You can't spend 10 minutes trying to figure it out. You got to spend 10 seconds or less. All right, so those were some examples here, like sodium chloride, metal, non-metal, magnesium oxide. We're going to learn all this name. We're going to learn the names later on in this chapter. So, but we've got to learn something first about ionic compounds that are made from metals and non-metals. And so, sodium chloride, which is table salt, we eat it. It's safe, tastes good in small quantities, especially on some potato chips or French fries. It's a very different compound than the sodium metal and the chlorine gas that makes up those two elements. Something happened to sodium, the element, to change it, to make it into the sodium that's in sodium chloride. They're both sodium, but something changed it. Chlorine, that's a very reactive and dangerous gas, changed somehow to become the chlorine that's in sodium chloride. The names change, as you might see something going on there, and there's an important reason. We'll get to that later. So the reaction between sodium, the metal, and chlorine, the gas, produces these two very reactive. Sodium metal, if you throw that in the water, it will explode. And lots of people like to do that. It's a fun reaction. It's very dangerous, though. But you take these two dangerous things, chlorine gas, it kills people, it can kill bacteria, it's just very reactive, it's very dangerous. Take those two things, mix them together, something changes, and you get the sodium chloride. And the thing that changes is the electron arrangement around the element sodium chloride. And so here's a sodium chloride, a picture of that, salt, it's a big crystal of it, that's awesome. And it's a very high melting point. And melting points are a distinguishing characteristic of ionic compounds. High melting points, 800 degrees Celsius, almost 1500 degrees Fahrenheit for salt, sodium chloride, table salt. So in this part of the video here, we're going to talk about what happens to an element when it gains or loses an electron. What happens to the size that's there? As we know, the electrons determine how things react. The electron configuration of an element or an ion then changes. We need to know what that is so that we can help use it to predict the properties. So ions are those things that make up an ionic compound. It's those elements that are in the ionic compound, but something's happened to them. They've changed. What happens? Well, one of the elements is going to gain an electron. So there's a prediction. You got to think about this. I wonder what's going to happen to the size of an atom when it gains an electron. So you have a couple choices. It gets bigger, gets smaller, or maybe it doesn't do anything, just stays the same. And you should think about it, make a guess, have a theory about it. What do you think? Well, the answer is it gets bigger. When you add an electron, the radius increases to the element. And I'll describe why in the next slide. But what do you think happens now if you lose an electron? What happens to the size of the resulting ion from its original atom? Once again, three choices: increases, decreases, stays the same. What do you think? Well, the answer is it gets smaller. If you gain an electron, you become more negative, but you become bigger. When you lose an electron, you become smaller. Why? Well, let's see on this next slide. This will help you, and it'll give you some real numbers behind this change that takes place. Let's take a look at the lithium atom. Lithium, number 3 on the periodic chart, but maybe number 1 in your heart, especially number 1 in your batteries. And lithium has 3 protons and 3 electrons. And it has an atomic radius of 152 picometers. Now, what happens when it loses an electron? Well, it's a metal, and metals like to lose an electron. When one electron is given off, the size decreases to 60 picometers. That's a huge change. Now it becomes a very small substance. the ion, lithium ion. So we always want to make sure we say lithium or lithium ion, because as you can see right now, they have completely different sizes, and it becomes a positively charged substance, and that has completely different reactivity than the uncharged element that was there. And part of the way we can explain this from the electron configuration. Lithium, with its 3 electrons, has the electron configuration of 1s2, 2s1. And you can add up the superscripts to get the number of electrons in that element, or in this case, or going to be in this case, the ion. If we look at the lithium ion, we would write its electron configuration as just 1s2. We'd say, well, where'd the other electron go? Well, in some reaction, the lithium gave off the electron, so now there's only 2 electrons there instead of 3. Well, lithium's still lithium, which still has 3 protons, so there's an excessive amount of, or 1 excess positive charge. It's not balanced by 3 electrons anymore, only by 2. Now let's take a look at what happens when a substance gains an electron. Let's take fluorine, for instance, one of the smallest elements on the periodic table, and it has 9 electrons and 9 protons. Now what happens when it gains an electron, say, from lithium? Well, it becomes much bigger. The radius, thought I had the radiuses on there. There we go. 64 picometers is the radius for fluorine. But when it gains an electron, we've got to change the name, and it changes its size. It becomes the fluoride. The ene goes to ide, and we add the word ion in there, and it almost more than doubles in size. It becomes much larger. And you can see that the sizes flip-flop. Lithium, as an element, was way bigger than fluorine. And just the loss of 1 electron makes all the difference in the world. And we can see lithium getting much smaller than the fluoride ion, and so it flips. And so now with this excessive 1 charge, 1 electron, it becomes a negative charge. We call that an anion. And then cations are those that have, like lithium here, an excessive amount of protons relative to electrons. Cations are like positive things, anion, negative. Now, how would we write the electron configuration for fluorine? Well, normally it's 1s2, 2s2, 2p5. That is the element as we would find it on the periodic table. However, when it gains an electron, it now fills up the p orbital, and we get 1s2, 2s2, and that additional electron is just added to the outer orbital, 2p6. Now, something you should notice about the orbitals now, we have full orbitals with these ions. This is a common occurrence. Electrons are given out of the outer orbital to either fall back to a full orbital set, or one is added to gain, or maybe more of a gain, but in this case, fluoride will just gain 1. So this happens all over the periodic table, and you can see in group 1A, they all like to form positive 1 charges. Why? Well, there's just 1 electron from their electron configurations, and they will give up that electron to fall back into a noble gas configuration, full orbitals. And those in the alkaline column, group 2, they will give up 2 electrons to fall back into that. And group 3A will do the same thing, so on and so forth. Now over on the other side of the periodic table, with these non-metals here, they like to gain electrons and become bigger. This was the opposite trend from the atomic radius that we saw earlier. So these are example sizes. You can get an idea of the size. Now you can see that they do get smaller going from left to right until they hit the non-metal areas, and then they balloon up. So we have to be a little bit more careful about how we think through sizes. Okay, group 1A, we say with all these +1 charges, they all act the same. They're going to have similar behavior there. So they have similar charges, they're going to have similar behavior. Okay, so these have really, these had lower ionization energies, except for, especially down here towards rubidium and potassium. These larger elements like to get rid of an electron that, with a low ionization energy. So how would you rank something in terms of sizes? Well, this is a trend that you should be able to try to start to figure out now. And so in some of your homework, you're going to just get some practice of being able to think about sizes, not just of atoms now, but what happens to the ions that are created when electrons are added or subtracted. So if you got this trend here between a nitrogen with a -1 charge, then a -2 and a -3, what would the order and size be? Is it getting bigger as we're going from left to right, or is it getting smaller? So you need to think about that. Increase, decrease, or maybe they just stay the same. Well, hopefully you're understanding that the size is going to change, and in this case, they keep on getting bigger. The sizes increase as you continue to add more and more electrons. The ions that result from that get bigger and bigger. So hopefully you can understand a little bit more about ion sizes now, ions and their electron configuration, and hopefully you recognize there's major changes taking place to an atom when electrons are gained or lost, and that makes all the difference in the world. All right, that's it for this video, and now you've learned a little bit more about ions.